Hello, everyone. Welcome to our channel, where today we're diving into an exciting topic in the world of astronomy, the search for exoplanets with technosignatures. With insights from renowned scientist Dr. Ravi Kopparapu, we'll explore how scientists are ramping up their efforts to find signs of technological life beyond Earth. So, buckle up as we set out on this cosmic journey to understand the latest in exoplanet discovery. Today we dive into a topic that fascinates me and our listeners. Your recent research on the detection of artificial greenhouse gases in the atmospheres of exoplanets. We've often discussed natural indicators, like water vapor and oxygen, but your work focuses on signs of alien industrial activity, such as CFCs. Interestingly, even though humanity has largely stopped emitting CFCs due to their harmful effects on our ozone layer, you're looking at their persistence on other worlds. Could you elaborate on that? Fascinating. So, if we consider the broader implications of your research, you're essentially looking at gases that could indicate technological activity by extraterrestrial civilizations, right? Could you break down for us which gases would be detectable as technosignatures, particularly those less harmful alternatives that a terraforming civilization might use? Absolutely, John. Our research has primarily focused on fluorine and sulfur-based compounds. These include industrially processed gases like sulfur hexafluoride and nitrogen trifluoride. These gases are potent greenhouse gases, making them potentially ideal for terraforming efforts on cold, Mars-like planets. So, in a scenario where an alien civilization is attempting to warm up a cold planet to make it habitable, they might use these gases. Exactly. The key here is their effectiveness as greenhouse gases. They absorb and re-radiate energy in the infrared part of the spectrum, which we associate with heat. This property makes them highly efficient for warming up a planet's surface. It's like wrapping a cold planet in a thermal blanket. We've recently published a paper analyzing several of these gases to see how effective they would be in terraforming scenarios and what their spectral signatures might look like from afar. That's a thrilling prospect, Dr. Karapu. Detecting such gases could lead us to undiscovered, actively terraformed worlds. It's like looking for cosmic fingerprints across the galaxy. Intriguing. So with advanced telescopes like the James Webb, we have the potential to detect these gases. It's a bit of a stretch with current tech, but imagine if we spotted a planet, similar to Mars, sporting a vibrant biosphere. It would be the ultimate impossible planet. Maintaining such an atmosphere would require a continuous output of these greenhouse gases, making this a potentially long-term technosignature, right? Yes, absolutely, John. This raises a fascinating point about the longevity and sustainability of such technosignatures. If we're using instruments like the James Webb Space Telescope to scan distant solar systems, and we notice two adjacent planets with similar atmospheric features, that's groundbreaking. In our own solar system, Venus, Earth, and Mars each have unique atmospheric chemistries, so discovering two exoplanets with analogous atmospheres would be quite the find. It suggests a sustained, possibly artificial influence on their climates. That's a profound implication. It means we're not just spotting random signals, we're potentially observing active, deliberate modifications of environments on a planetary scale. Dr. Karapu, it's like peering through a cosmic keyhole into the ongoing stories of distant worlds. This discussion takes an even more intriguing turn when we look at neighboring star systems. Imagine discovering not just one, but multiple terraformed planets gradually expanding their influence across their solar system. Believe it or not, this scenario is becoming a critical aspect of technosignature research. That's right, John. What we're considering now is not only the possibility of adjacent planets sharing similar properties, but also what those shared characteristics might reveal. When we analyze the spectrum, essentially splitting the light from these planets into various colors, it's like decoding a cosmic message. The chemical signatures we observe can tell us about the processes occurring on those planets. It's an active area of research that blends what was once considered mere science fiction with tangible, cutting-edge science. And what's particularly compelling about this is the shift from the ambiguity that often shadows astronomical research. Traditionally, in fields like radio astronomy, we might catch a signal once, but never again, leaving us to puzzle over whether it was a true detection or just a fluke of nature. But with this method, if we repeatedly detect similar atmospheric signatures from different planets, it could strongly suggest an artificial origin. It's like following breadcrumbs leading us to potential interstellar civilizations. Dr. Karapu, it's fascinating to consider these combinations of greenhouse gases. It seems almost unimaginable that nature alone could create some of these specific mixtures, like those involving CFCs. How do you address the natural versus artificial origin in these cases? That's a great point, John. Nature does indeed have a knack for surprising us. For instance, there are studies that suggest CFCs could potentially be produced by volcanic activity. However, many of these compounds, especially the ones we're most interested in, require sophisticated industrial processes to form. This complexity often hints at an artificial origin. So, it's not just about finding a single suspect gas, but looking at the broader chemical context. I always emphasize to my colleagues and anyone interested that no single gas by itself confirms a technosignature or biosignature. We need to see a pattern or a combination of gases that fit the environmental context of the planet. If we detected just one type of CFC, I wouldn't immediately claim it as a technosignature. We'd need to identify additional gases in the same region to support that conclusion. If an observer were looking at Earth from a close distance, not that our gas concentrations are necessarily high enough, they'd observe something quite striking: the oxygen disequilibrium in our atmosphere, a clear marker of biological activity. This observation, combined with others, provides a comprehensive picture that can differentiate between natural processes and possible technological activity. This brings us to a crucial point. When we start detecting these industrially processed compounds like fluorine or chlorofluorocarbons, especially in conjunction with others such as nitrogen dioxide visible in the optical spectrum, it paints a compelling picture. So, essentially, this profile of gases could point directly to a civilization, correct? Absolutely, John. Observing these gases across different wavelengths gives us a fuller understanding. If these industrially processed compounds show up consistently alongside natural atmospheric components, it significantly boosts the argument that we're seeing the influence of an advanced technology. What exactly are technosignatures? These are signs of advanced technology that might be detectable in outer space, indicating the presence of technological civilizations. Dr. Ravi Kopparapu and his team focus on specific emissions, unusual energy patterns, and other markers that go beyond simple life signs. We'll break down how researchers use these indicators to narrow down their search in the vast universe. Space telescopes like the Hubble and the upcoming James Webb are crucial in the search for exoplanets with technosignatures. These powerful tools can detect the faintest whispers of light from distant worlds, revealing clues about their atmosphere and possibly signs of technology. Let's discuss how these telescopes sift through cosmic noise to capture potential technosignatures from light years away. Recently, astronomers have identified several exoplanets in the habitable zone, where conditions may support life as we know it. Dr. Kopparapu sheds light on these discoveries and the potential they hold for finding technosignatures. Each new discovery not only excites the scientific community, but also refines the technologies used to scan the cosmos. Despite the advancements, there are significant challenges in detecting technosignatures. The vast distances, faint signals, and our limited technology make it a daunting task. Dr. Kopparapu explains the innovative solutions being developed to overcome these hurdles, such as new algorithms and more sensitive sensors. What does the future hold for this thrilling field? With projects like the Breakthrough Listen and other initiatives, the next decade could be golden for technosignature research. Dr. Kopparapu is optimistic about the advancements in AI and machine learning, helping to analyze data faster and more accurately than ever before. Spectroscopy is a key tool in identifying technosignatures. By analyzing the light spectrum from distant planets, scientists can determine the composition of their atmospheres. Dr. Koparapu elaborates on how this technique can reveal gases and pollutants that might indicate industrial activity or advanced technology. One of the earliest methods in the search for extraterrestrial intelligence is listening for radio signals. These signals, if detected, could be evidence of a technologically advanced civilization. We'll delve into the history of this approach and how Dr. Koparapu and his colleagues are refining these techniques to increase their chances of success. Another fascinating method involves searching for artificial light sources. On Earth, city lights are visible from space, and similarly, lights on distant planets might indicate the presence of civilizations. We'll explore how scientists detect these artificial lights and the technological advances aiding this search. Citizen scientists play a crucial role in the search for exoplanets and technosignatures. Platforms like Planet Hunters and SETI, Rear Home, allow enthusiasts to participate in data analysis. Dr. Koparapu emphasizes the impact of these contributions and the collaborative nature of modern astronomy. Infrared observations can reveal heat emissions that might indicate advanced technology. For instance, large-scale industrial activities could produce excess heat detectable in the infrared spectrum. We'll discuss the instruments used for these observations and their significance in identifying potential technosignatures. The Drake equation has been a guiding framework in the search for extraterrestrial life. Dr. Koparapu revisits this famous equation, discussing its variables and how modern discoveries and technosignature research might alter our understanding of the likelihood of finding intelligent life. Dyson spheres are theoretical megastructures built around stars to capture energy. If such structures exist, they could be detectable through unusual light patterns. We'll explore the concept of Dyson spheres and the ongoing efforts to find evidence of such colossal engineering feats. Optical SETI focuses on detecting laser signals rather than radio waves. Advanced civilizations might use lasers for communication, and detecting these signals could be a breakthrough. We'll look at the technology behind optical SETI and its potential to uncover distant civilizations. Artificial intelligence and machine learning are revolutionizing the search for technosignatures. These technologies can process vast amounts of data quickly, identifying patterns that might indicate technological activity. Dr. Koparapu explains how AI is becoming an indispensable tool in this field. While technosignatures are a primary focus, understanding exoplanet atmospheres and potential biosignatures is also crucial. We'll discuss how studying these aspects complements the search for technosignatures and what they can tell us about the habitability of distant worlds. The search for technosignatures is a global effort, with scientists from around the world pooling their resources and knowledge. Dr. Koparapu highlights some key international collaborations and how they enhance the search for extraterrestrial intelligence. New telescopes like the Extremely Large Telescope, ELT, and the Giant Magellan Telescope, GMT, promise unprecedented capabilities. These instruments will provide more detailed observations of exoplanets, increasing the likelihood of detecting technosignatures. We'll preview what these future telescopes could achieve. Theoretical models help scientists predict what technosignatures might look like. Dr. Koparapu discusses how these models guide observational strategies and help interpret data, bringing us closer to identifying signs of technological civilizations. The search for extraterrestrial intelligence raises important ethical questions. What should we do if we find technosignatures? How would contact with an advanced civilization affect humanity? We'll explore these profound questions and their implications for society. Science fiction has long inspired the search for extraterrestrial life and technosignatures. From books to movies, these stories fuel our imagination and shape scientific inquiry. Dr. Koparapu shares his thoughts on the interplay between science fiction and scientific research. Public interest in space exploration is crucial for funding and support. Dr. Koparapu emphasizes the importance of engaging with the public and educating future generations about the search for technosignatures and its significance for humanity. Analyzing the vast amounts of data collected by telescopes and sensors is a monumental task. We'll discuss the challenges faced by scientists and how advancements in computational power and algorithms are aiding in the search. While space telescopes garner much attention, ground-based observatories are also vital in the search for technosignatures. We'll look at some of the key ground-based facilities and their contributions to this field of research. What would it mean to find a technosignature? We'll speculate on the potential scientific, philosophical, and societal impacts of such a discovery, considering how it might change our understanding of the universe and our place in it. In addition to technosignatures, scientists are also searching for alien artifacts within our solar system. Dr. Koparapu discusses the intriguing possibility of finding relics of ancient or current extraterrestrial technology closer to home. The search for extraterrestrial intelligence, SETI, has evolved significantly since its inception. We'll trace its history, milestones, and how modern SETI efforts integrate technosignature research to enhance the search for intelligent life. Quantum technology holds promise for future space exploration and the search for technosignatures. We'll explore how advancements in quantum computing and communication could revolutionize this field and open new avenues for discovery. Interstellar probes, like the proposed Breakthrough Starshot, aim to explore nearby star systems. These missions could provide direct observations of exoplanets and potential technosignatures. We'll discuss the prospects and challenges of such ambitious endeavors. Oceans are considered essential for life, and finding exoplanet oceans could be a major step toward detecting life. Dr. Koparapu explains how scientists search for oceans on distant worlds and the implications for finding technosignatures. The Fermi paradox questions why, given the vastness of the universe, we haven't yet detected extraterrestrial life. Dr. Koparapu offers insights into this paradox and how the search for technosignatures might provide answers. Biosignatures are signs of biological life, while technosignatures are indicators of technological civilizations. We'll compare these two approaches and discuss how the search for technosignatures builds on the foundations laid by biosignature research. Gravitational microlensing is a technique that uses the gravitational field of a star to magnify the light of a distant planet. This method can reveal exoplanets that might otherwise go undetected. Dr. Koparapu explains how this technique aids in the search for potential technosignatures. Industrial pollutants in an exoplanet's atmosphere could be a strong indicator of technological activity. We'll delve into how scientists are looking for these specific chemical signatures and what they might reveal about distant civilizations. Fast radio bursts are intense, brief flashes of radio waves from distant galaxies. Some scientists speculate that FRBs could be signals from advanced civilizations. We'll explore this theory and the ongoing efforts to study these enigmatic bursts. Planetary rings, like those around Saturn, can provide clues about an exoplanet's environment and potential for life. We'll discuss how detecting and studying these rings might offer insights into the presence of technosignatures. Weather patterns on exoplanets could hint at advanced technology, especially if they show signs of artificial modification. Dr. Koparapu discusses how scientists study these patterns and what they might reveal about technological civilizations. Polarimetry measures the polarization of light and can provide unique information about exoplanet atmospheres. We'll explain how this technique is used in the search for technosignatures and what it can tell us about distant worlds. Space debris around exoplanets, similar to the satellites and debris orbiting Earth, could indicate advanced technology. We'll explore how scientists look for such debris and what its presence might mean for the search for extraterrestrial intelligence. Space-based solar power systems could produce detectable technosignatures. We'll discuss how these systems might be identified and what their detection could tell us about the technological capabilities of other civilizations. Exotic materials, such as those with unusual optical or magnetic properties, could be indicative of advanced technology. Dr. Koparapu explains how scientists search for these materials and their significance in the quest for technosignatures. Interferometry combines the signals from multiple telescopes to create a more detailed image. This technique is invaluable in the search for exoplanets and technosignatures. We'll discuss its applications and how it enhances our observational capabilities. Diverse perspectives can lead to innovative approaches in scientific research. We'll highlight how cultural and linguistic diversity among researchers enriches the search for technosignatures and fosters global collaboration. Technological relics, such as ancient satellites or probes, could be remnants of past civilizations. We'll explore the methods used to search for these relics and what their discovery might imply about the history of technological development in the universe. Gamma-ray bursts are the most energetic explosions in the universe. Some theories suggest they could be linked to advanced civilizations. We'll examine this intriguing possibility and the efforts to understand these powerful phenomena. Magnetic fields protect planets from harmful space radiation and are crucial for maintaining atmospheres. We'll discuss how scientists detect these fields and their importance in assessing the habitability and technological potential of exoplanets. Space missions like Kepler, TESS, and future missions are pivotal in the search for technosignatures. Dr. Koparapu explains how these missions contribute to our understanding of exoplanets and the quest for technological civilizations. Synthetic biology could create life forms with unique biosignatures that might be detectable from afar. We'll explore how advancements in this field could impact the search for technosignatures and what it means for our understanding of life. Detecting artificial intelligence, AI, in the cosmos is another fascinating avenue. We'll discuss how scientists theorize about the presence of AI and the methods they use to search for signs of artificial intelligence in distant worlds. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.